So what we're going to do is we're going to look at more identities. This time we're going to look at the Pythagorean theorem identities in terms of trig. When we're looking at the unit circle, we remember that the Pythagorean theorem is x squared plus y squared equals 1 squared. So we take each of our values, we square them, it's equal to 1 squared. Now, if you remember, our opposite side is y over 1, which means it's just y, so that would be sine. Our adjacent side would be x over 1, so that would be cosine. So when we're doing this, x squared is technically cosine squared, and y squared is technically sine squared, and 1 squared is 1. So that's how we're getting the first formula. Sine squared plus cosine squared equals 1. Now, based on that formula, we're going to get the other ones. So with the other ones, what we're going to do is we're going to take our sine theta plus cosine theta equals 1. And in my first case, what I'm going to do is I'm going to divide it by sine. Now, sine over sine is 1. Cosine over sine is cotangent. And then I forgot to put the squareds. And then 1 over sine is cosecant. So that's how we get our second one. And then our third one, we take the sine squared theta plus cosine squared theta equals 1. And you could probably already guess, instead of dividing it by sine, we're going to divide it by cosine. And sine over cosine is tangent. So you can see the tangent right here. Cosine over cosine is 1, so plus 1. And 1 over cosine is secant. So that's how we get each of the formulas. What we're going to do is we're going to simplify these. And we're going to be using our 3 formulas that we went over today. And then we're going to be looking at the last lesson too and remembering all those transformations also. So with the first one, 1 plus tangent squared. So if we're looking at it, we see the tangent squared. Tangent squared is right here. We see the plus 1, and so we see that our answer is secant squared theta. Our second one, we see the sine and the cosine, and notice that our first one, sine and cosine, is equal to 1, so it's 1 over cosine squared x. And we know that 1 over cosine is secant, so technically this is secant squared x. For this one right here, we have cosine and secant. Notice there's no squareds, so we're going back to what we did last time, where we just convert it. We have the cosine over 1, secant. We change that to 1 over cosine. We keep the cosine the same, and secant is 1 over cosine. Now looking at this, we see that the cosines cancel, and that gives us 1. And we do keep, change, flip, and we flip this right here and multiply it by cosine x. Cosine times cosine is cosine squared. And this one's a little bit of a jump. 1 minus cosine squared, if we look at our formula, sine squared, cosine squared, if we were to move the cosine to the other side and subtract it, what we notice is that it's equal to sine. So that means that this answer is sine squared x. Now for the next one, 1 minus sine squared x, this is just like what we were talking about on this other one. It's going to be cosine squared x. Once again, the reason why is if we look at our original, sine squared plus cosine squared equals 1. If we were to subtract the sine this time, instead of the cosine, what we would get is 1 minus sine squared is equal to the cosine squared. Here we have 1 plus cotangent, and notice that 1 plus cotangent is equal to cosecant. So we have cosecant squared theta over secant squared theta. I'm going to turn these into sines and cosines. So that's 1 over sine squared theta, 1 over cosine squared theta. Keep, change, flip. So I'm flipping the second one to cosine squared theta over 1. And cosine over sine would equal cotangent. Now for the next one, what we have is secant squared minus 1. If we look at this, what we're doing is we're adjusting it. Notice that our bottom equation has the secant squared. If we were to bring over the 1, we would subtract it, and so then that means that it's equal to tangent. So we have the secant squared theta over the tangent squared theta. Secant, we know, is 1 over cosine. And tangent is sine over cosine. Now, keep, change, flip. We're taking our dividing one, and what we're doing is we're flipping it. So we have cosine squared theta over sine squared theta. And the cosines cancel, and so what we're left with is 1 over sine squared theta. Now, 1 over sine is cosecant squared theta, and that right there is our answer. Now, going back to factoring, last time we were factoring, now we're going to solve by factoring. How we know it's solving is because it's equal to 0. So we're going to do the same thing as last time. Two numbers that multiply together give us negative 16. Add up to negative 6. That would be negative 8 and 2. So we have x minus 8 and x plus 2. For the next one, because we have a leading coefficient, we're multiplying them. Two numbers that multiply together give us negative 12. Add up to positive 1. That right there would be 4 and negative 3, but because of the leading coefficient, we divide it by 4, and so that would be x plus 1 because, I didn't finish off that last one, equal to 0, so we have the opposites, 8 and negative 2. So with this one, we have the x plus 1, and we have the 4x minus 3 equals 0. So our answers are always the opposites. Opposite of 1 is negative 1. This one's a tricky one because the opposite of negative 3 is 3. But because of the 4, we're going to divide it by 4. One way that helps us out is we look at our x method, whatever the opposites are, that right there also tells us our answer. So the opposite of negative 3/4 would be 3/4. And for our last one, we see that they're binomials. So we take the square root, and that gives us x minus 7 and x plus 7 equals 0. So we do the opposites. So x is equal to 7 or negative 7.